Welcome to new video. In continuation with video number 3, I'm taking some more examples and their solution to clarify all these things, whether the decimal expansion of a rational number is terminating or non-terminating. So let's talk about condition for rational numbers to be terminating or non-terminating. When any number written in form of P upon Q, there is property of Q. Here Q should not be equal to 0, and if prime factors of Q are only 2 and 5, this number can be expressed as terminating decimal. P upon Q will be terminating only if Q can be expressed as product of prime factors as 2 and 5 only, or simply in form of 2 raised to the power n multiplied by 5 raised to the power m. For non-terminating condition, P upon Q will be non-terminating only if Q cannot be expressed. Q is not equal to 2 raised to the power n multiplied by 5 raised to the power m. Means there is a scope of some other prime factor as well, except 2 and 5. Had there been 3, 7, 11, this expression will be non-terminating. I have taken this lesson in 9th class video. For more clarity, you can visit or you can watch this video. I have prepared a video for school for class 9th. It's video number 2 for terminating and non-terminating decimal representation. You may watch this video as well. I am taking some examples here to show you clearly how we can express the decimal representation of these questions. Without actual division, in 9th class we have to show it by method of division, but in 10th we will decide directly by looking at Q only. I am solving this first question for you. Without actual division, show that each of the following rational number is a terminating decimal. Express each in decimal form. Later on, you have to express this in decimal form. We have to do two tasks here. First, we have to decide whether rational number is terminating and how we can express its decimal form. I am taking your first question. It's 23 divided by 2 raised to the power 3 multiplied by 5 raised to the power 2. Here we see that Q is in form of Q is equal to 2 raised to the power n multiplied by 5 raised to the power m, where n is 3 and m is 2. From here we can relate this. If Q can be expressed as product of 2 and 5 only, so certainly this number will be terminating, as Q is equal to, or Q is in the form of 2 raised to the power n multiplied by 5 raised to the power m, the decimal expansion is terminating. How can I express this in form of decimal form? In decimal form, here I will use a technique for it. You are aware that if denominator is 10, this number will carry one place of decimal. If it is 100, this decimal number will carry two places of decimal. So, in order to express the denominator in raised to the power 10, I have to equalize these values n and m. I will make powers of both factors equal to the higher power, means 23 upon 2 raised to the power 3 and 5 raised to the power 2. I need 3 here, and in order to make this power 3, I have to multiply it by 5. What will you get? 5 3s are 15, 5 to the 2s are 10, and 1 11, 115 upon 2 raised to the power 3 into 5 raised to the power 3. This power will add up with this 2. So now it becomes 115 upon 2 into 5 raised to the power 3. That is, it will be 115 upon 10 raised to the power 3, which is 115 over 1000. Means this is your thousands place, then it will be your hundreds place, and it will be tenth, and here you can fix your decimal. So it will be 0.115. Simply I have expressed this number, your question number 1, as decimal expansion. You have to decide whether this number is terminating and non-terminating when expressed in decimal. Clearly it will be terminating, and the decimal expansion can be found out using these steps. I think I have made it clear. If now I will take one more, question number 3. You have to express 171 upon 800. 171 upon 800. First of all, you have to decide whether this is terminating or non-terminating. For it, I have to split this 800 as product of its prime. So clearly it is of the form I am expressing it as product of prime. In later video, I have done such problems for you. I think now it is clear for all students. 2 से divide किया 400, 2 से divide किया 200, 100, and now it is 50. Go on 25, and now it is 5, 5. So here 800 can be expressed as 2 raised to the power, calculate 1, 2, 3, 4, multiplied by, sorry, it's 5. 1, 2, 3, 4, 5, and 5 raised to the power 2. So this number can be expressed as 171 upon 800, or 171 upon 2 raised to the power 5 into 5 raised to the power 2. So clearly there are only 2 and 5 in prime factorization of the denominator. So as per condition first, I have told you earlier, this decimal expansion will be terminating. Decision number 1. And how you can divide it? How can you change it into decimal expansion? We have two options here. In first, you can use the same technique as earlier, or you can simply divide 171 by 800. I am taking the same practice I have taken earlier, 171 upon 2 raised to the power 5 into 5 raised to the power 2. What should I do here? I have to multiply this number by 5 raised to the power 3 on both sides. So what will you get? 171 multiplied by 125 upon 2 raised to the power 5 and 5 raised to the power 5 means 2 multiplied by 5 raised to the power 5. In denominator, you will get 5 zeros after 1. And what is product of 171 and 125? Let's calculate. 171 upon multiplied by 125. 5 1 the 5, 17 5 the 85, 12 1 the 12, 12 7 the 84, and 1, 85, 12 1 the 12, and 8, 5, 7, 3, 1, 2. So it is 21375. Then fix decimals. 1, 2, 3, 4, 5. It will be 0.21375. You can work in the same way. I am leaving these questions for you. I have solved 2 out of these 6 questions. Try out the remaining sitting inside your room. Next. My next question is almost of the same type without actual division. Show that each of the following rational numbers is a non-terminating repeating decimal. Here, we are not asked to find decimal representation as it is non-terminating repeating decimal, or it will be quite large. Here simply we have to express this number 11 upon 2 raised to the power 3 into 3. Here Q is not of the form 2 raised to the power n multiplied by 5 raised to the power m. There exists one more prime factor, which is 2, other than 2 and 5. Therefore, the decimal expansion of 11 upon 2 raised to the power 3 into 3 is non-terminating. If you have to express, then you have to go through the long process. This step I am taking for you that it will be non-terminating repeating decimal. So it will be in condensed form 11 upon 2 raised to the power 3 is 8, 3 are 24, and simply you can divide by 24. Divide 11 by 24, taking 3 to 5 decimal places as it is a repeating decimal. So, can you find out? In this question, this part should not be done. It is only for your practice. You have to see yourself that certainly it will be non-terminating. In previous video, I have taken such exercises. I am taking next one. For this part, we were solving these questions from 7th onward. I have taken such type of problems in class 9th video. I have mentioned it earlier. I am taking 2 for you. I am solving first question for you. Second, no need to solve second. I will take fourth and first. These are simple questions. You have to multiply both sides by 10. Here you have to multiply both sides by 100. Here you have to multiply both sides by 1000, as the repeating string is of 1 decimal, 2 decimal places and 3 decimal places. Here the case differs. So let's solve it. As per pattern, let this number 0.8 will be equal to some number x is equal to 0.8 bar. I am writing 8 bar as 8, 8, 8 and so on. Take this equation as 1, multiplying both sides by 10. It will be 10x. This number will be, by multiplying 10, this 8 will skips to 1's place and one more 8 appears from this. It will be your equation number 2nd. Subtract equation 1 from 2. By subtracting equation 1 from 2, you will get 10x में से 1x less करिएगा, you will get 9x. Here clearly this string will be cancelled and you will get 8.000 and so on. So x is equal to 8 upon 9 here, which is in form of p upon q. The were following as fractions or rational numbers or in form of p upon q. express each of the following as fractions or as rational numbers, or in P upon Q form. In P upon Q form, all these three things are the same. So I'm taking this one more exercise for you, 0.1 and 2 bar. One does not repeat. So let our number x is equal to 0.21. 2 repeats here. It means x is equal to 0.1222 and so on. If I take this one here, in my previous video I have told you the pattern how we can multiply these numbers by 10, 100 and by 1000. So what's our need? Simply I have to multiply. If this bar is over only one digit, you have to multiply it by 10. If bar lies over two digit, you have to multiply it by 100, sorry, by 100. And if this string is of 3 digit, means it contains 3 digits under this bar, you have to multiply this equation by 1000. So again I am multiplying equation 1 by 10 on both sides. I will get 10x is equal to, this decimal will skip here, 1.222 and 2. 1 2 appears from here. This is our equation second. Again subtracting, we have to take the same technique. Subtracting subtracting 1 from 2. Subtract this. You will get 9x and subtract this number from this. How you can subtract 1.2222 and so on, and this number 0.1222 and so on. If I subtract this, I will get 0 0 0 0 from this side, and finally 1 here and 1 here. It will be your remainder. So it will become 1.1. Sorry, it will be your difference. I told you about remainder. X is equal to, now becomes 1.1 upon 9. Simply it is 1.1 का डेसिमल हम हटा रहे हैं. इस डेसिमल प्लेस हटाने के लिए 10 से डिवाइड करिए and it will be 11 upon 90. I think you understood all the process, and if yes, you must try all these questions shown in this video. Try out yourself. If you are finding some difficulty, then try to consult these questions with me. I will solve them out in next video if someone asks.